Hello, everybody. My name is Jim Zwicka, and welcome to Connected Factory, get insights from data to improve OEE. I am the Director of Manufacturing Solutions at Vertex. I am joined with John Heller of Product Marketing. A little bit about ourselves. I've been doing visualization solutions my entire career. In the realm of product lifecycle management, digital transformation, and manufacturing processes. I've been implementing solutions in automotive, heavy equipment globally for literally my entire career, with the whole intention of getting visualization implemented and easily usable across an extended enterprise. And so I'll throw it to John for a little bit of his overview.
Yeah, thank you, Jim. Been here at Vertex now for a couple years, but prior to joining Vertex, spent the better part of 18 years across a couple different companies in the manufacturing sector. First being Dassault Falcon Jet, where I held different roles in engineering, moved into kind of a liaison role between engineering and the shop floor, which presented many a learning opportunity when it came to understanding how do you get the engineering information translated in a meaningful way to the manufacturing environment. And then did a couple of different roles in options management, configuration management. Then moved to Danfoss, where again held some roles in supply chain, product development again, and also within product marketing. So got to a lot of firsthand anecdotal experience, if you would say, in the manufacturing industry here when it comes to exchanging data.
Yeah, thanks, John. I mean, and that kind of goes back to the premise of why we started Vertex. The core group of our company actually helped build out one of the first visualization frameworks back in the 90s. And before then, there was really no conceivable way to bring large amounts of CAD models, 3D CAD models into one environment to enable collaboration. So digital prototyping collaboration is what we called it back then. It's now known as digital twin, IoT, those sort of things. But the initial framework that we built did allow you to bring in very, very large models and interact with them. But that solution, which is still used primarily today, is for the most part stuck in engineering, and the ability to take this information that's trapped in the engineering world, in the manufacturing world, and truly make it usable across the enterprise is still a very, very big challenge today. And we're going to go over a lot of those barriers with specifically with the ability to access this easily across an enterprise. And so if you look at this slide here, and you see what's highlighted, what we're going to focus on today is the factory yield. And there's always a challenge. You want your factory to perform better, you want your takt times to reduce, you want your quality to be better, and you want the overall utilization of your equipment to be as high as it possibly can. Now, if you look on the right side, it lays out really the initial sort of high-level structure of information, siloed information on the bottom, and then essentially siloed personas on top. And the challenge is, if you are, say, in manufacturing, you will need 3D models, product 3D models from your PLM system. However, you need it consumed or aligned to your ERP or MES systems, ideally. And the methods that are done to achieve that today have been lacking. And so, Vertex ourselves are, we've built a visualization platform to really make that journey, that process easier, while also maintaining connectivity to those groups. And so, so the core of this core of this webinar today is we're going to walk over some of the problems of that space, and then how Vertex can play a good part in making this data flow a lot easier. So if you think about, digital thread, digital twin, and if you look on the right side, it's a very high level sort of layout of different groups, different personas, and the whole point of that on the right is this to show that there's confusion or there's broken connectivity across the classic personas there, whether it's manufacturing, engineering, sales, that sort of thing. But the first bullet point that you can see there, it talks about departments being siloed, and it says both technical and cultural. So engineering tools, they may be biased towards using product lifecycle management tools specifically built for that. So using latest design intent, latest released, effectivity dates, that sort of thing. Manufacturing would be more interested in planning and using ERP systems, such as say SAP or those sort of things, and then also MES to do manufacturing execution systems to first, how is the material going to flow through the factory, and then second, how are the operators at the stations going to assemble with via MES system. The point being though is that all of these groups tend to use different tools to do their job, and then oftentimes they will modify the data itself to be more aligned to how they do their job. I did work at a company, I won't say which one, but the design center that I was working actually had engineering, product engineering, and manufacturing design in the same facility. And there was a huge banner in the manufacturing. As you entered the manufacturing planning space, the banner said, manufacturing planning, where engineering dream meets reality. Meaning that whatever the engineers thought of, now the manufacturing team has to figure out how to build it. And then they essentially they don't trust the engineering team to build things that are easily manufacturable. And it just kind of highlights the different cultural aspects. Are the engineers actually building things that are intentionally meant to be challenging to the manufacturing group? No, of course not. But the ability for them to communicate correctly and collaborate in dialogue is just not one of the drivers that that persists across an organization often. And so it's something that you need to address. And like tool-wise, is there a one single tool that will work across all of the organization? No. So then how do you break down the so what's necessary really to collaborate? How do you make sure information gets where it's supposed to get while still letting each of these groups use the tools that they need, how they need to use them with the information, how they want it. And so that's really, of these bullet points, this is one of the bigger challenges is the human aspect and the tools. The second we have here, and these are all very high level, of course, but a lack of true enterprise PLM strategy. Now, not PLM as a tool, but you're doing product lifecycle management, whether you realize it or not. It could be on the back of an envelope, or it could be with a very expensive PLM system. And oftentimes the PLM frameworks and structure tend to reside primarily in the engineering space. And then other groups just are sort of added on or are part of it, but it's not necessarily an end-to-end strategy per se. So if someone in sales or a customer wants to talk to sales and they want to do a configure price quote event, and then the sales team wants to sell to the customer, but in this day and age when configurability, infinite configurability is more of the rule versus the exception, sales very often don't realize, or they don't know, can we build this thing, but they want to make a sale. So they essentially cross their fingers, throw it back to manufacturing and engineering to see, is this an even buildable product? And that unknown, that manual process is really highlights a lack of PLM strategy. And you want to be able for the the sales team to be confident. They know we can build this because we have connected our information flow. We were able to talk and engage in a way that allows us to be to sell with confidence what the customer wants. And so again, it's just a symptom of some of the process not really meeting the customer where they are, or the sales team where they are to do things that ultimately move product. The third one here, like systems of record, systems of engagement are disconnected. So engagement, of course, means your UI UX. It means how are you touching the data that is known as the master data and being able to use it in a performant way or to do your job. Even within engineering, historically, if you're using a PLM system, you may have multiple instances of that PLM system where one part that you're looking for, one assembly that you're looking for could be on one instance and you're not aware of where it is. So that's within engineering. So think about, in manufacturing, if engineering releases a new assembly that's meant to be on a product, manufacturing could say, well, that's great, but I already have a huge inventory of the last assembly that we were using. I have to use all that before. And so it just shows you that the structures, the systems, the awareness for the people making decisions can really be in a silo, and the awareness of that information and can hinder good decision making, or can cause confusion across the groups. And so again, we're just highlighting some of the problems and some of the realities of today, and there's just a lot of work you can do to make a thread a true thread and align things together. And we'll go over how we think Vertex can help that here shortly. So similarly, you have data trapped within these systems, and it's challenging to access. So even if the information is in a disconnected system, the data themselves for the individual may have access, but it's hard to get, or they're infrequent users, or the user interface for them is not built in a way that makes their job easier to do. And so what you'd prefer to do, as opposed to making the engineers, the sales team, those personas adjust for the tool, what should happen is that data should be delivered to those groups in a way that is how they work. So the sales should be able to do a configure price quote. The manufacturing group should be able to see the latest engineering released data in the context of a fixture or a cell or a manufacturing process. The service technician should have their digital twin readily available in their tools that they use, whether it's on a tablet, on a phone, that sort of thing, to allow them to truly be able to do their job and have this information enhance what they're doing, versus making them leave, go find something and try and be able to do that and then keep in the context of their regular job. Oftentimes you may have all that information available to these groups, but the process or the experience for them to go get it will cause them to not want to go there, and you must fix that and make it very, very easy for them to see what they need to see in the context of their job. And so and that kind of really goes back to the experience. So I kind of hit those both at the same time, where if it's cumbersome for those users to be able to do their job, even if that information is technically available, the information should meet them where they are, how they're doing their job, versus making them depart what they're working on and go use that tool. And so that's really the key, in a high level, to go over those 5 bullet points. So I'm going to throw it over to John, let him really kind of summarize what we just went over, and then we'll get into some demos for you.
Yeah, thanks, Jim. The all those challenges, or what we should say are actual realities that we see many companies facing when it comes to uniting their digital thread across the entire enterprise. I live firsthand in many of these different roles, and had opportunity to start out in engineering and then move to different what one might say are downstream teams, from engineering and got to be on the flip side or the receiving end of trying to interact with engineering data, trying to make it useful, put it into different types of systems of engagement so that feedback could be gained and decisions made. And really what it boiled down to was this whole idea of just the viscosity of data. It's so big, it moves so slow, it takes forever to move. It's hardly useful once it arrives to those downstream users in order to be able to interact, to contribute back to the digital thread in a meaningful way. And so there's all these speed bumps or barriers in getting that information, let's say, out to your factory in this case, in order to be able to create those experiences where you can optimize your layouts, where you can optimize the process flow, be able to understand what's happening in your facility and be able to make real-time decisions to improve your overall equipment effectiveness and really have a tight control on your quality. If you go to the next slide here, we eliminate those series of speed bumps, let's say, and getting that information out to downstream users, out to other teammates, and in this case, out to the decision makers in your factory, those that are interacting with the process flows, those that are monitoring asset utilization, let's say, trying to optimize flows, trying to place equipment. And all of those previous speed bumps along the way of being able to flow data downstream, be able to provide feedback to those that need to make those appropriate decisions are essentially eliminated now with Vertex. And so this, instead of having this one-way street, very complicated data speed bumps, data barriers along the way, and not being able to communicate that across the enterprise and into the digital thread, now becomes this very seamless two-way street utilizing the Vertex platform. And so we're going to jump into a couple different demos here that highlight this, particularly as we think about your factory and being able to optimize it. We think about this sort of assembly flow and what we would say is a process digital twin. Being able to get this holistic view of how your product is moving through the factory, the different bottlenecks, let's say, that arise in it, being able to have that information packaged in such a way that very real-time and impactful decisions can be made. Well, again, as Jim sort of hit in the digital thread reality, when we get into this mode where we're trying to optimize assembly flow, we see, again, there's this disparate and disconnected data. You might have sensors on all of your equipment out on the factory floor. You might even have sensors across multiple factory sites, let's say within a region or perhaps globally. And you've got all of this data coming in and very difficult to connect. Leading into kind of that second bullet point there of being able to effectively understand that. Jim will kind of give us a demo here of how we bring that data together to enable insights.
Yeah, sorry to rush you there, John.
That's all right.
But so just based on that slide, this is our 3D geometry. This is a factory. Below here, you would have sensor information that's come in based on weld efficiency or some and-on system connectivity. But if you think if this is how you got access to geometry back or to sensor data back in the day, you would have to go in and really work with it to see, well, okay, based on what's just come in, is my process healthy or is it not? But with Vertex, you can take this information, align it to 3D geometry. So if you notice, you're able to go in, have your full factory layout, and then as I step through these rows of sensor data, you'll notice that what we've done is we've taken the incoming information. We've done it, in this case, we've done it through AWS SiteWise, and we've mapped the 3D geometry to the sensor data so that you can see, during this event, we had stress, the robots were stressed or the other areas were working fine. And The whole point being is that we want to be able to take your 3D geometry and apply not necessarily reams of information, but to be able to collate it in a way and then apply it to the 3D geometry so that you're able to see effectively, how the factory is going and how it's performing. I'll throw it back to you, John, for the other one.
Yeah, thanks, Jim. And lastly, we'll look at sort of this challenge when it comes to factory layout and planning. Back in my previous role, when we had the ability to flex systems, it was always very challenging to understand how we could optimize our process flows, gain a complete view, and be able to modify that. It was much easier to modify what you had in existing than to, let's say, throw up more brick and mortar. And so we see many companies that we talk to with the inability to be able to view factory at full scale, bring in different assets to be able to lay them out, and then be able to package that in such a way that decisions can be made. I'll flip it back to you, Jim.
All right, so let's hop over then. So as John mentioned, the Vertex platform was built to be scalable beyond really anything that has existed up to now. So you can bring in your full 3D geometry. You can also bring in your factory geometry, I should say, and then you can also merge it with your CAD, so your product CAD. So if you notice here, you have over here the chassis is being welded together. You have robots that are walking it through. And we've built some snapshots here that allow you to essentially have your design intent factory layout so that you can see at this point, we will start assembling the model. And at any given time, all of this geometry is, of course, changing. And so you could, if the seats get changed or the chassis get changed, it can get married back together with this so that you, with the factory as it's being designed. So everything, you can always have a visual alignment to, if we were to build this today, this is what it shall look like. And all of this is essentially connected to the native sources. So whether it's your PLM system for the product CAD, or maybe manufacturing CAD, your ERP system for your process flow, you can bring all of that together and then quote unquote solve it. And then we would then deliver a 3D representation of that to allow you to see, if we built this today, this is what this shall look like. But if you notice, it's very performant. With Vertex, you don't actually have to have, this is all running through a browser. This will work just as nicely on an iPad as it will on a high-end engineering laptop, because all we're doing is delivering images to the device. So we really eliminate a lot of the barriers that you would have had to provide this to your teams to be able to have access to in a quick way for them to realize, okay, yeah, you know what, I think we can put this many tires here now, that sort of thing. And so that's really the whole point, is that Vertex solves the problem of aligning 3D visuals, no matter how complex, no matter how big, no matter from how many different sources, and it allows you to generate an experience that helps you do your job. All right, let's go back to. So if you think about Vertex itself, and I just kind of summarize that to an extent, the way we built this platform is we really had to, when we got the team back together to rethink visualization and make it a next gen solution and a platform, there's a few main things we needed to eliminate. One was the model size. So not just the product model itself, but literally bringing in massive models together and then being able to interact with it on any device in a very, very performant way. One thing that gets skipped often with companies that to try and build solutions like this is they're very hardware dependent. And as such, then the concurrent users, or they try to simplify models, that sort of thing. And so therefore, what we want to do is that we want to eliminate all of those things. So any size model, bomb size, polygon size, any number of users. You can have thousands of users concurrently, and they're working independently with the models, doing what they need to do on any device, and then also meeting them where they work. So you can embed, we can embed into current tools that they're using so that or help them shape new tools through our SDK, so that you really allow them to have the information come to them with how they're doing their job versus forcing them to go away or diminish, you know, how they would normally do their job because they got to run over here to find geometry. So anyways, I'll throw it back to you, John, if you have any insights or maybe there's questions out there.
Yeah, actually, Jim, thank you. Thanks for walking through that. We do have time for a few questions, and we do have a few here to go over. One of the questions here was, you know, we don't really have CAD for factory. Are you able to render point cloud data?
Yeah, in fact, we are. And looking at time, let me just quickly show you guys that if you'll humor me for a second. I did have this set up. I thought we ran out of time, but since there's a question, let's go ahead and go for it. So this is a point cloud concept, and so as John just asked, you know, oftentimes the factories are old and you don't have the ability. No one's going to go make a 3D CAD representation of something from before, but they may go out and do a point cloud. And if you notice, the way Vertex works is once it gets into our ecosystem, it's no longer really in any CAD format, which then allows you to actually take different sources of information and merge it together. So this is a fixture or a jig that would be coming in. We are able to position it in the point cloud area, and it allows you then to essentially do studies to define, you know, if we bring in all of this together, will this work in this space? And it's again very highly interactive. It's aligned to your native sources, but it really gives you a very good idea to understand, oh, nope, we got a problem here. If we put this here, it's going to hit this beam, for example. And then it allows you to essentially have collaboration events with your team to realize if we do it this, now we know that it'll be good. So that sort of thing. So hopefully that answers that question.
Yeah, thank you. And I think we got time to just get one more in here. How is this different than other visualization solutions? And this came in here, Jim. I think you walked through it at a high level point, but let's just circle back around again and reiterate, you know, what is it that really sets Vertex apart here when it comes to being able to provide context to your factory data?
Yeah, and you're right, John. Many could go, well, you know, we have all of these tools. Some of these companies even offer cloud solutions for us to use. But when we started Vertex, we knew that there was scalability issues. First of all, generally, more often than not, the device is given the task of doing the rendering. So the geometry gets cached to the device, then the hardware renders and then delivers the experience. That could be via WebGL or some sort of graphics language frameworks. There could be, oh, well, no, there's things in the cloud too that we use, and it sounds like that's exactly what you guys are doing. And in fact, we're not doing it that way. The more often, nearly every circumstance, if they've built a cloud solution, they've essentially kicked the hardware problem up to the cloud. So they've spooled up virtual machines with GPUs and expensive hardware. So they're renting the hardware versus buying it, but that's still very expensive. Both cost-wise, and then often you're still having serious issues with the number of users concurrently and the model size. So Vertex, we don't do any of that. In fact, we don't even use GPUs to do our rendering. We are in the cloud exclusively. We don't rely on WebGL or your device to do anything. All the device needs to be able to do is receive an image, not unlike watching a YouTube video, for example, but it's interactive. So our platform renders through massively distributed CPU clusters. We render individual fragments, we composite an image together, that image gets streamed to your device, but it happens so fast that you actually feel like you're working with 3D geometry, even though you're not. Security, usability, all that actually is a huge value add to that, which we don't have time to get into.